Okay, I think we are now going to take the other aspects of motion. As I said earlier on, that the translational motion, I told you that the translation motion has the x-axis, it has the y-axis, the x-axis, and the z-axis, which is the projectile. Now we have taken that of the x-axis, which is the three equation of motion I was telling you. And if you know these three equation of motion, which are the derivation, the first one from the what do you call it, from the definition of acceleration, and the second one is from distance, average speed times time, a matter of you substituting your v to UAT, and the third equation is still from here. It's also for you to substitute for t from the first equation. Now let's take the aspect of the distance along the y-axis. Now for the y-axis, and look at it, I said it. This is the y-axis, this is the x-axis. That on the x-axis we have derived it, and I say that is the basic, you have to know that. Now for the y-axis is a little difference in your comparison. Now you have v is u plus at, you have s is ut plus half at squared, and you have v squared is u squared plus 2as. Now when it comes to the y-axis, you are not talking again about acceleration, normal acceleration. Now your acceleration becomes acceleration due to gravity. And now it is either positive or negative. Positive in the sense that the body is falling along with gravity, is positive. But when the body is thrown up against gravity, it becomes negative. Then the next thing again is that s, which is distance, is no more distance, it is known as the height. It's known as the height. So that is, so now if you now understand these two aspects, that a is now plus or minus g, then you also know your distance equivalent now to height, no more distance. You throw an object up, you say the height of the building has a height of, an object is falling from a height of, not from a distance of. Now you can now rewrite this first equation. It will now be v is equals to u plus minus gt. That is now the first equation along the y-axis. The second equation will now become h is equals to ut plus minus half gt squared. That is what the second equation will be. The third equation will now become v squared is u squared plus minus 2gh. That becomes the third equation. So you see that the first three, you see that this one is really the basic derivation, but you have now seen the one falling under gravity, perpendicular from height. So these are so we have gotten the three equation here, we've gotten the three equation here. Now for the projectile, now we now have to understand a concept about it. So now let's go to the projectile. We are still dealing with translational and linear motion. This is just a subclass to the first class. First class is motion, so this is just a subclass to it. So we are now talking about the projectile now. So let's now go to projectile to explain. I think I can clean on here. So let's go to projectile to explain the concept of an object thrown upwards. Now, for projectile, really, this is what happened. You threw an object. Let's say this is the object. You throw an object at an angle. Projectile, what are the things moving on projectile? You throw a stone. The stone, you are throwing it at an angle. So it's going to move. This is how the movement will go. The movement will go this way. This is how it will move. It will move this way. You fire a bullet. The bullet is going to, when you fire the bullet is going this way. It is going to be falling gradually due to gravity. Now, if a plane, look at it, a plane is moving horizontally, and the plane on motion. There are two things, because by the time we come to questions, there was a question that a plane is stationary and it dropped a missile. At that point, you are walking under the y-axis. You are walking under an object thrown vertically upward or coming vertically downward. But when the plane is on motion and it drops a missile also, the missile is going this way. It's going through projectile, a trajectory parabolic nature. So it will go this way. So please, these are some illustrations about projectile. So now when you project, you send something, it will go this way. Now, when it's going that, what are the things we want to know? Number one, the things we want to derive now is number one, there is an horizontal distance, which they call range. Range is the horizontal distance. The horizontal distance. Then there is what we call the maximum height. The maximum, this is the vertical maximum height. At this maximum height, do you know what is happening? The object was going, it goes to a peak and it starts falling back. We are going to understand some of the things that happen at that point. Then number three, you want to also, so this is the maximum height. Then number three, you want to know the time it goes to the maximum height. And I want you to understand this. The time it goes to the maximum height is the same thing as the time from the maximum height down. So let's say this one is T2. T1 is equal to what? T2. The time to get to the maximum height is equal to the time it gets from the maximum height to drop back. Now, this time of flight, capital T. This is time of flight. You call it capital T. So your T is equal to T1 plus T2. What is the time of flight from here down to the final destination? And therefore, since these are equal to this, you can now say T is equal to 2T1. So the time of flight can be 2 times. So these are the things we want to know. Number one, we want to know the maximum height. Number two, we want to know the time of flight. And number three, we want to know how to calculate the range. How to calculate the range, which is R. So these are the things you want to know in terms of projectile. Now, in knowing this, let us now explain some things, because you have to know some little things about the velocity. Now look at it. You drew an object vertically this way with an initial velocity u. I'll write it clearly. You drew it with an initial velocity u. This is your x and this is your y. Now, and at an angle of theta. Now we have to do a resolution. You throw an object with initial velocity with u. Now this u is having two components, because as this object is moving, it's moving along the x-axis and it's also moving along the y-axis. This velocity is resolved in such a way that there is a vx taking the object along the x-axis, and there is a vy taking the object along the horizontal vertical axis, and this one along the horizontal axis. So if we have to resolve this, look at it, we have your u, initial velocity, we have your vx, the velocity by which, and you have your what? Your vy. That is also taking it vertically. Because look at it. When you threw the objects at this point, which is the maximum height, the Vx is the one dragging it this way, taking the object this way. That is Vx. Vy is the one. This is so Vx, this is Vx, this is Vx, this is Vx, this is Vx, this is. So it is Vx that is taking it along the horizontal axis. Then V is Vy, is Vy. At this point, that's what I want you to know. At this point of the maximum height, your Vy becomes 0. The Vy is exhausted because as the object is going up, gravity is affecting it, so it's gradually decreasing in velocity. It's just like by the time we are going to take some questions, you throw an object vertically upward. As you throw it vertically upward, it gets to a maximum height and it can no longer go further. It comes down. So you see that the velocity will be decreasing until it gets to 0, then it falls back. So the same thing with projectile. As you throw the object will be going up and it's also going along the x-axis. It's taking two motion. So when it gets to this point, it can no longer go up, it's not dropping. At that point, Vy, not Vx, it's still moving. So at that point, Vy becomes 0, but your Vx still continues. So please, you have to take note of this when it comes to projectile. And now that is what we are resolving here. Look at your Vx and look at your u, and this is your angle theta. So now, because you are not given Vy, you are not given Vx. So how do you get, but you are given u, an object is thrown at an angle of 30 degrees to the horizontal, velocity is about 50 meters per second, so you are given u. So what is if you resolve this from your SOHCAHTOA? This is opposite. You want to look for Vy. Opposite all over hypotenuse. And you now say your Vy all over u is equal to what? Sin theta. So your Vy is equal to u sin theta. So you have gotten this, which is the vertical component of the velocity. That is the vertical component. You see why I say you should know the derivation of the question of formula. There was a question that was asked. A body is projected at an angle of 30 degrees with a velocity of 20 meters per second to the horizontal. And the next question, they say, and it travels for a time of 5 minutes or thereabout. The next question, they say, what is the vertical velocity? So you see that if you know the formula of projectile, vertical velocity. The vertical velocity is Vy is just the value u 20 times sin theta and 30 degrees. So you see how you should know derivation of formula when it comes to physics. And all that I'm going to teach you in physics, everything in physics to fill your syllabus, I will be deriving all the formula with this simple method, which you must practice to derive so that you can understand it and you can be able to use it. So when we got it, now let's go to how do we get Vx, which is the horizontal. Horizontal, this is adjacent all over hypotenuse. So you can say Vx all over u is equals to cos theta. You understand? So what is Vx? Vx will be u cos theta. So please, this is now the horizontal component of the velocity. So this is the velocity that is taking the object this way, and this is the velocity that is taking. And if you use your Pythagoras theorem to square this, you will still get your u the same thing. So please, this is what you need to first of all know before we now go to the derivation. So you know the Vs. It is not this u you will use in solving, because the u is already resoluted, in the sense that one part of that u is taking the object up and one part of the u is taking the object along the horizontal axis. And at some time, Vy gets to 0 or Vx remain constant. So now, let's now go to solve it now, bearing in mind these two formula. Vy is u sine theta and Vx is u cos theta. Now, if you know these two formula now let's go to our derivations or formulas now directly. Now, look at this now. If you are now, look at what we want to derive now is your fire this way, this is your u, this is your angle theta. Now we want to calculate, and this is the height. Now we want to calculate the time to get to the maximum height. So number one, time to get to maximum height. Now, please look at this now. We want to calculate the time it gets to the maximum height. We want to calculate the time of flight first, but let's pick it one after the other. The time to get to the maximum height. Now, what is now the question? To get to the maximum height, which velocity is taking us to that maximum height? Is it Vx or Vy? You will now see that it is Vy because it is Vy taking it vertically upwards when we resolve Vy. So you know that we are going to use u sine theta. Now, from the formula, listen, from the formula of V is equals to u plus minus gt. Because we are using this, we are using vertically upward, not here. We are using because it's taking upward. Now, the first thing is this: are we using plus or minus to the vertical height? The object is going to the vertical height. Is going against gravity. So it's going to be V is equals to u minus gt. Then the next thing, at the maximum height, what is the final velocity? At the maximum height, you know I told you, maximum height, what is Vy? Vy, final velocity will be 0. That's why it can no longer go upwards. It's not coming down. So at that maximum height, your final velocity is 0. Now, what is your initial velocity? The initial velocity, which is u. So what is that initial velocity in terms of the one taking it up? The initial velocity, of course, taking it up. So it is not u, it is what? U sine what? Theta minus what? Gt. If you do this, you now get your gt is what? U sine theta, where your t is what? U sine theta all over g. So you now see that the time to get to the maximum height is u sine theta all over g. And you know in my first derivation, so what is the time from the maximum height to this place? Is still the same u sine theta all over g. So what is the time of flight? Now I told you the time of flight with capital T is 2t. So the time of flight will be 2u sine theta all over g. So please take note of that. The time of flight is capital T from here down. I told you in the earlier, I said from here to here is T1, from here to here is also the same thing. So just multiply by 2. So that's why you have 2u sine theta all over g. So that is the time of flight. So we are finished with the time of flight. Now the next thing is that we want to calculate what is the maximum height. So the next thing we want to calculate the maximum height. So number 2, the maximum height. So we want to calculate h. Now, please, by the time we come to question, this is not the only height. So sometimes they can say, what is the height at 2 seconds? What is the height at 1 second? And the rest. But at the maximum height is, by the time we come to question, you will understand better in the usage of this formula. It's not just this formula that is important. It's your understanding how to derive it. By the time we come to question, I will give you the question that will tell you that sometimes they will not ask you for the maximum height. They will be asking you there are different heights. There are some heights here. It's like H1. There's another height here, H2, another height here, H3, different heights like that. So sometimes they can ask you of height in that level. So what do? You can't use the formula directly, but the derivation of this formula will give you the understanding. So now, what is the maximum height? You are using v squared is u squared plus minus 2gh. Let me put it capital H because it's maximum height. Now, maximum height, what is the final velocity? It is 0. initial velocity, taking it to the maximum height, is still u sine theta square. Going to the maximum height is equal to negative 2gh. So you have your 2gh is equal to u square sine square theta. So what is your h? Is u square sine square theta all over what? 2g. So that is the height. That is the maximum height. U square sine square theta all over g. Then the last thing we want to talk about is the range. How do you get this range, which is the horizontal distance? How do you get the range? Now, the range, let me put it here. How do you get the range? You're drawing an object. How do you get the range here? Now, the range is simply the distance. Is simply the velocity times the time, and this range is the whole time. You understand? So, what is the velocity? What is the velocity taking it along the horizontal axis? It is what? It is u cos theta times what is the time of flight? The time of flight is 2u sine theta all over what? G. You see? As simple as that. The velocity, the range, the horizontal distance. What is the velocity taking it along the horizontal distance? It's not u sine theta, it's u cos theta. So it is u cos theta multiplied by what is the time they use? Time, the total time. So when you multiply this, you are going to have 2u squared sine theta cos theta all over g. 2u squared sine theta all over. Now the next thing is this. Now this is correct, but to make it more neater, more shorter, there is a part again in mathematics we call trigonometry. And we have 14 laws of trigonometry. Now, when I come to trigonometry, I'm going to teach you everything about it. So, you see trigonometry, you have to use it. In trigonometry, there is a law that says that 2 cos theta sine theta is equals to sine 2 theta. 2 cos theta sine theta is equals to sine 2 theta. Now, what is that going to be? So, we are now going to have your range, which is what? U squared sine 2 theta all over g. So that is now your range. U squared sine 2 theta all over g. So this we have simply derived the 3 aspects of translational motion along the x-axis, along the y-axis, and along the z-axis. And I've explained it all. So in the next class, we are going to look at either 2 classes to now solve questions about projectile, about linear motion, throwing vertically, x, to now understand better the usage of this formula. So thank you very much, and see you in the next class. You're welcome.